Hello students, sorry for the delay. My name is Sumit Sagar Hota. I am a PMRA PhD scholar, IIT Palakkad. This is the first week of the live discussion section. Here we will cover lecture 1 to lecture 5 by Professor Ashok Desai, IIT Kanpur, of the subject Turbulent Combustion Theory and Modeling. In this section, I just divided this section into two parts. First, we will solve some of the MCQ questions, basically theoretical or very less problematic, and in the next part we will do some numerical problems, mostly based on the problems from your textbook. I actually follow one textbook. Actually, sir also follow one book, that is SR Turn. Actually, there is lots of books available. One of the books that I also follow for the problems, mostly the problems whatever I will solve for this course, all the problems are from this section. If there is any other problem I will solve, I will obviously mention you in this. Book name is An Introduction to Combustion, Concept and Applications, third edition, 2017, McGill, by SR Turn, Stephen Turns. First we will go for the MCQ part. Okay, the first question is, on what basis is the coal classified? The thing, the answer will be physical and chemical compositions. Okay, depending upon the physical and chemical composition, we can specify the. Okay. Okay, and what are the analysis if you want to know? Okay. Some of the question may be asked like the common tests. Okay, coal. Okay, or to find the commercial value of the coal, what are the perform? Okay. Okay, what are the tests? One is approximate and one is unproximate. what is the percentage. Approximate analysis gives characteristics of coal such as percentage of moisture. Okay, mass or volatile matter. Ultimate analysis, approximate analysis is the important thing. Ultimate analysis is the basic analysis of coal, application, temperature, heating value thing. What you take from this whole heating value. Okay, don't confuse now with all these terms. Gradually when you go through this, what is heating value, most heating value will be covered in the next question. Which are the main constituent of a fuel from the given? Okay. Carbon, nitrogen. Carbon and nitrogen cannot be a fuel. Carbon only is there in the exhaust, so it's wrong. Oxygen and hydrogen. Okay, actually this question is basically if you see this question is actually incomplete. Okay, constituent of a fuel means means you may confuse. Okay, hydrogen can be a fuel, okay, and oxygen hydrogen will be the correct option. Okay, but here actually fuel means mostly it is telling about the hydrocarbon fuels, okay, like methane, okay, methane, ethylene, all these things. Okay, so you have to, this kind of question may come. That hydrocarbon, it means that hydrocarbon fuel. So oxygen and hydrogen cannot be the option. Okay, any hydrocarbon fuel, if you see this combination CXHY, it will be there. Okay, helium, oxygen, helium mostly we means that helium, for that we need too much temperature, so obviously we are not using helium as the fuel as of now. Maybe in future, because of by use of plasma technology, we can use helium as also the fuel. What are the use of electrostatic precipitation in the steam power plant? Okay, electrostatic precipitation, the term. Okay, which power plant we are talking about? Steam power plant. Okay, okay, so this electrostatic precipitation basically used for what? For removal of fly ash. Okay, the use of your what? Remove the fly ash. Because you see, to remove the steam, to remove the feed water, why you are removing feed water? We have to reuse it or something like that. Okay, so draw the coal power into the boiler. Draw the coal power powder into the boiler. Okay, this is why you are drawing coal power powder, all this. Okay, when you see these options now, you also, this is having no importance in this question. Okay, then you obviously, if you don't know anything also, fly ash. Okay, fly ash removal. Okay, we can reuse nowadays. Using fly ash, many people are making bricks. Okay, fly ash bricks. You can, if you can nowadays, if you see, this waste fly ash people are using for fly ash brick, fly ash and search work. Okay, which of the following law is not used in the combustion calculation? Okay, and this is a very tricky question, because if you don't know the three laws, then you obviously cannot answer this question. Okay, so you have to know these four laws, then only out of four you can find out which one is the wrong option. Okay, this kind of question you can expect in your exam. Okay, so okay, very simple thing. Conservation of mass, everybody in the world, everybody knows this. Conservation mass, obviously a correct option. Continuity equation you can apply. Okay, so this is correct. Okay, law of definite proportion. Okay, this law, all these things we will see in future. This is also a law. Okay, conservation energy, obviously a very good law. Okay, the law of multiple, you see, mostly proportion, they are very simple thing you can assume is that the proportion, whatever proportion you are taking, it cannot be multiple. Okay, you have to take a particular proportion for a fuel. Okay, you cannot take multiple proportion for a fuel. Okay, for a particular combustion reaction, you have to take a particular proportion. Okay, it cannot be multiple. Okay, simple. So this cannot be the your option. Okay, there cannot be multiple. The answer is, but this multiple proportion is also a law. Okay, that's the reason this tricky question set. Okay, in combustion we don't use it. There is a multiple proportion law. This is not used in combustion. Maybe other fields we can this. Okay. So obviously, if other law you anyway you will study, but this law you are not going to study in your combustion syllabus. Okay, so you should obviously know what exactly this multiple proportion law tells us. For example, two elements. Okay, let it be element 1 will combine with element 2. Your element, element 1 will combine with element 2. Okay, then what will happen? Form a what? New compound. Let it will be E3. Okay, which is contain some of the mass ratio of E1 and E2. Okay, maybe I can tell E3 comprises of x percentage of E1 plus y percentage of E2. Because of that, it forms a new product. Okay, this is the new product. Combustion, we don't use multiple components, multiple elements together at a time. Are not there. Okay. You have any doubt? You can.
So combustion means fuel will be there, oxidizer will be there. So means more than uh, means multiple compounds.
Actually, here actually it's not about here elements is not represented as the your what you called space means species is okay. For example, I am taking, okay, how I can explain you this. For example, I am taking one reaction of methane reaction, methane plus air having one reaction, then your carbon dioxide and water vapor will come. Okay, so here this means whatever this means methane reaction is there, methane is not going to change anywhere. Methane's thing, I am not changing anything. I am just reacting with the methane and I am getting the product. Okay, here the game is different, that it's telling that methane, then we are again adding methane with some other fuel, maybe hydrogen, another fuel. We are adding, for example, I am adding methane, again adding hydrogen, I am getting another fuel. So this is what the thing is actually telling. Okay, here maybe you're getting na, means we are not talking about three fuels here. Okay, we are talking only one fuel and we are just doing a combustion. Okay,
Okay, sir.
there is a definition. CH4 CH have how many number of carbon? 1:4 ratio already fixed. Okay, that's what the thing. You gradually know all these things. Kind of tricky question. Okay, that's the reason I just mostly focus on this question, because obviously you will go to directly law of multiple proportion. That's the reason taken this. Okay. Get your answer, I think.
Yes, sir. Yes, fine.
Okay, next question. Which of the following is the ideal gas equation for 1 mole of gas? Very simple question. It's mentioned 1 mole of gas. Okay. So obviously wherever this n is there, na, just remove this option, because n equal to only 1 mole, it's there already given. Okay, wherever this n, just remove. Here n is there, remove. Here n is there, remove. Here n is there, remove. Okay, one option left. Answer is the correct formula. Pv is equal to nRT. Here n is equal to 1. Equal to R. What is R? Is your universal gas constant, 8.14 joule per mole Kelvin.
Kilojoules, sir.
Huh?
Kilojoules, sir. Kilojoules.
Actually, I don't get it. Huh? What happened?
Kilojoules are units.
Okay. Confusion is there then. You see, if the unit is joule, okay, always take mole. Okay, for example, I want to tell it to kilojoule. Okay, the unit should be 8.314 kilojoule per kilomole Kelvin. Okay,
Okay, sir. Yes, sir. Thousand get cancelled. Yes.
correct unit. Okay, either you will get the like this, you will like this. This is incorrect. Or more. Okay. Which of the following reaction is not involved in combustion calculation? I already told you this methane reaction. Okay, this is obviously comes under our calculation. Okay, you know how carbon monoxide will obtain. Obviously, this is the correct because 2C plus O2 gives rise to 2 carbon monoxide. Okay, this is also a correct reaction. Next, also water reaction is also correct. 2H2 plus O2 gives rise to 2H2. This is the correct reaction. Now, if you see this reaction, N2 plus O2 gives rise to 2NO. Okay, this actually seems like it's correct. Okay, also looks like it's correct, but it's actually wrong. Why it's wrong? Okay. What is the number of moles of products are there? Okay, mostly if you see this kind of reaction, NOx formation cannot be done by this way. Okay, NOx always form in the exhaust. Okay, for example, I can show you the correct way of how this NO will come. Okay, for example, I will give okay, the correct way is, you see, CH4 plus, let it be 8 times 2 plus 3.76 times N2. Why this all these things? Okay, mostly equal to X times O2 plus Y time H2 Z time N2. Okay. For example, in place of this, I am providing some excess amount of what? For example, this nitrogen is there. Okay, and for example, I am supplying some excess of your oxygen or excess of this and nitrogen. For the Zn2 is there. For example, one more species we can add, maybe uh, S time of NO. Okay, yeah, by this NO will come. For example, we have incomplete combustion. Oxygen in product means there will be incomplete combustion. Okay, sorry, initially I told excess, it's not excess. Yes, for example, whatever air, when you just directly done this much calculation, okay, don't consider NO, and if you calculate all these values, you can get X as your 2 6 equal to 2y, then y is equal to 3, a is equal to, you know, x plus y by 2. Okay, 5. Okay, then equal to what? 0.76 times 8.1. But if you, when you get this S, when you consider this much part, okay, for that what is the thing, but what you have to do? Okay, you have to means whatever the, this is the correct way. Okay, it's the stoichiometric reaction. Okay, for example, reaction you are having in place of A, for example, you have less, maybe A by 2 you have, okay, or A by 0.75, okay, you, if for example you have 0.75 times A, okay, or 0.5 times something less you have less, okay, so that there will be there is incomplete combustion, obviously the NOx formation will be there, okay. That's the reason why for different engines we are using superchargers, turbochargers, all these things, okay. Why? So that this we can just gas whatever this formation, okay. And by reusing this thing, what we uh, means we don't have any NOx formation, okay. The other way around, for example, we don't have much of the air, okay. We have much air, okay, excess of air, okay. Instead of this S air, what we will get S air, okay. Now instead of this, it will come carbon monoxide will come, okay. Then it will be K times A. So carbon monoxide will come when this is your air. Um, okay. So okay, and in future also you can, okay, there are the thing cases, either this or this. The two cases cannot come together. Maybe in your future you can see this may be as your elementary reaction, okay? See in it as elementary reaction, okay, where this N2 plus O2 also reaction possible, okay. In global reaction there is two kinds of reaction: global reaction, elementary reaction. There is, I think, chemical kinetics chapter, you have this thing, okay. But when you go for the means elementary reaction, this C option will be correct. If the in the question it is asked which of the following is the elementary reaction, if this is the question, then the answer obviously will be okay. I also see obviously because it's not the reaction, not the reaction, this is the reaction. Thing you can take away. Don't confuse global reaction and elementary reaction, and what is all these things we will cover next. Next question. Find the volume of air required for the complete combustion of 1 meter cube of acetylene and the weight of air necessary for the combustion of 1 kg of food. This is a problem. Start problem. First of all, what is this? What is the fuel? Okay, first in any kind of combustion question, first job is to write down the reaction. So first I have to identify the fuel. Okay, acetylene is the fuel. Okay, then how it's reacting with whom it's reacting with air. Okay. Okay, find the volume of air required for the complete combustion of 1 meter cube of acetylene and the weight of the air necessary for the combustion of 1 kg of fuel. Okay, it's here it's air written, okay. You can take also means oxygen also reaction will be same, only 3.76 N2 all these things will come into existence, okay. You can take oxygen plus directly write down the balance reaction for CO2, okay. So now, okay, so here 44 plus, you can calculate the your what is the C2 H2 whatever. First your job is to what is the air required. Okay, air required per meter. Okay. 1 meter cube acetyl already given. Okay, and combust 1 kg of fuel. Okay. 5, you know, 5 is for oxygen. For your, you have to find out per meter cube. Then these are your moles of what? For you understand. Okay, we'll skip these questions. We'll go to directly to. Okay. Actually, some of the concept required which is not maybe not be covered. Maybe better to see. Okay. Question I don't need to worry. We have this instead of this numerical. Better we should solve our numericals from the books. Okay, from the standard. Now this is the case. Okay. Consider the gaseous mixture consisting of 5 kilomole of hydrogen and 3 kilomole of oxygen. Determine the hydrogen and oxygen mole fraction, the molecular weight of the mixture, and the hydrogen and oxygen mass fraction. Okay. If you know all this question thing, na? Okay. Things. This kind of question, short forms. Okay. Whatever the name directly, obviously, this question will not come, but some of the parts may come in it. Answer this. In this question, what are the things given? Just true. 5 kilomole of hydrogen and 3 kilomole of oxygen. What we need to find? X mole of hydrogen, X mole of O2, molecular weight of the mixture, I of hydrogen. Okay. So here you see, if you see the hydrogen and oxygen mole fraction. Okay. One is your mole fraction and one is your what, mass fraction. So these are the things. So first x is your what, you can tell chi also, your mole fraction. Capital Y, mass fraction. So formula for 5 kilomole of hydrogen given, divided what is the total, plus with only 5 hydrogen and oxygen are there. Okay, so one only for because there is only two fuel hydrogen and oxygen, you can do 1 minus the, okay. Okay, so now we have oxygen, hydrogen, and what we can find, we can find mixture fraction, molecular mixture, molecular weight of the mixture. Okay, so molecular weight of the mixture is equal to x of H2 into molecular weight of H2 plus x of O2 into molecular weight of O2. Substitute all these values. Okay, all these things get the molecular weight 126 to find, get the mass divided by molecular of the mixture. Find out y of H2 of H2 equal to calculate y of O2 is 1 minus y equal to 1 minus 0.90 to 2 rid of the mix of H2. Now next question. Consider a mixture N2 and argon in which there are 3 times as many moles of nitrogen as there moles of argon. Determine the mole fraction of N2 and air, the molecular weight of the mixture, the mass fraction of N2 and air, and the molar concentration of N2 in kilomole per meter cube for a temperature of 500 Kelvin and a pressure of 250 kilopascal. Okay. This is similar question. Okay. Whatever now we do, just the same thing we will do. Just here what they given, temperature they involve and pressure they involve. Okay, that's the only thing. Take a as compared to the previous. Okay. Proceed same way as this question. There N2 and air is there. N2 air mixture is there. Something also mentioned 3 times air. Okay, consider mixture of N2 and air in which there are 3 times as many moles as N2 as there moles of air. Okay. What does it mean? N of N2 equal to times of the temperature, correct? You also go with me directly. If you have any doubt, just at the end you just ask, or whatever point you don't understand, just ask. So that you won't forget again. Directly similar question you can expect in your exam. Directly this much big question on there will become coming. To find x of N2 of air molecular to the mix Y1 to of air. Important thing in this question is the third bit, n N2 by volume. Here volume I am representing like B. Yes. Okay. With velocity is also there. Volume like this. Why I am just n N2 by B? Because in the question you can see determine the mole fraction of N2 and air, molecular weight of the mixture, mass fraction of N2 and O2, the molar concentration N2 in kilomole per meter cube or at some given temperature and pressure. Okay. This is your molar concentration of N2. Okay, you can represent the molar concentration of N2 as N by V. Okay, number of moles of N2 divided by the total volume. Just you should note total volume, not the volume specific volume. Okay, given way we just have to, for the last bit we have to do some. Okay, so I just quickly solve. Now what is the case here? Okay. Okay. 3 n of air. But I4. Three zero. 2. Then what? 1 minus what is molecule summation of xi rate of I just two species into molecular I. I'm directly writing 0.75 20 28.14 to 0.25 39.94 for your AR to the molecular weight somewhat 30.998. The weight of first we get N2 is equal to 0.75 the rate of the N2 28.014 30.998. So y of N2 is what 0. What is y of AR 1 minus of N 0.6 of AR is equal to 0.3. Already we done. Okay. Okay. Just apply PV. That is P of equal to N of N2. Okay. What is P of we can write down P of N2 as equal to X of N2 into P, where P is thermal pressure. Okay. The way B substitute P of N2 in this equation 1. Okay. So what we will get we for 5 whole per meter. Okay. So now this question, okay, you should note that why this question number is not matching. In previous question, if you see number, I am writing 2.5. Okay, then the next previous one 2.3. Okay. Not continuous. Don't confuse. Okay, here 2 means chapter 2. Okay, 3 means 3 new exercise. The book is a turn. Okay, I already mentioned the book name here. Okay, this is the book name I am following. Okay, I think this this book also kind of standard books. If you can see the lecture standard textbook by Dr. Ashok Desar. Don't confuse. Directly taken from the exercise. Okay, next 2.6 LP in whole CO. CO2 and O2. First I done. What are the things? Uh, 0.1 and O2 will be your mole fraction 0.9. Okay. What else given? Temperature 100 Kelvin. 9. Standardized enthalpy of the mix. That's what is about standardized enthalpy. Okay. Let's write. I will write down H bar of the mixture. H bar means bar indicates the standard temperature and pressure. Okay, standard state. Sorry, standardized state we can represent it by bar. Okay. No, actually bar represents your per kilomole. Okay, this is for per kilomole. 1 degree sign kind of thing is there, that is represented. That I'll now come. So these are the things give assumption I can take. Ideal gas behavior. So we know the formula H bar of CO2 because here in this the standardized solution of CO2 and O2 taken into consideration. Okay. So what will be H bar of CO2? Okay. We can split into enthalpy of formation plus sensible and H bar of all these basic, what is sensible, all these things that I am not going to cover. Those things already cover in your class. I only here means if there is any doubts in this that thing I'll theory related I think ask in the question and answer forum in NPTEL. Okay, if there is any theory related doubts, all these things. Okay, here only problems, all these things I will solve. Okay, be first clear all your theory related doubts before coming class. After this class also, any theory related doubts are there, you can ask in the question and answer forum. There another TA will be there, will clear all these doubts possible. If I am there also, I can. Okay. And whatever problems, whatever now I am solving, if there is any doubts there, you can ask me. Okay. And also one thing, you try to follow this SR-Ton book. Okay, whatever now I am, so because mostly throughout the section I will follow this book. Okay, whatever the sections covered in your class. Okay, go through all the examples that in that particular whatever sections it's cover. Okay, whatever lectures it's cover. Okay, if you don't do the examples in your subsequently, then obviously when I am solving these questions, obviously you don't understand anything what I am solving. Okay. If you really want to learn this subject, obviously you have to be very careful while learning. Give some time. Okay, all the examples, all these things, then it will be for you to solve this accessible, because similar problems are there, examples and in exercise. So what I am doing, actually, where all these datas are there. Okay, these data you can find from this SR-Ton book appendix. You can, if you go there, you can find all these appendix A. These datas are there. Okay, SR-Ton you can find. Okay, follow that book and it will be very easy for you to understand. Okay, 38945. Negative sign means that there is some, obviously heat loss is there. So and of H of O2 comes out to F of OB plus delta H bar of O2. Okay, so the real question, real thing also you can know. Okay, oxygen is already formed in the universe. Oxygen is already occurring species. Okay, so if some species is there which is already occurring, okay, and then you are telling, okay, carbon dioxide is already occurring. Okay, carbon dioxide is already occurring, already there in atmosphere. It's not already there, it's we are creating carbon dioxide. Okay, through the vehicles and through the different power plants. Okay, with the air pollution, all these things, we are creating the carbon dioxide. Carbon dioxide not already there in the atmosphere. Okay, carbon is there, the nature, but carbon dioxide is not there. Okay, that's we are burning something, some hydrocarbon species. Carbon dioxide is there. Okay, don't confuse with that. Okay, that's the reason minus 393,546, all these things help your formation is there. Okay, so we have to supply some, what this negative sign means, you have to supply some heat from the carbon dioxide. Okay, again to raise the temperature, what price should be there, 400 Kelvin. Okay, the question, if you see what is the temperature, 400 Kelvin it's mentioned. Okay, 400 Kelvin is mentioned. Okay, that means enthalpy rise will be there. For that, how much is 40,003, that temperature is required. Okay, that is what only I mentioned. Okay, similar, so the oxygen is already there. Okay, this enthalpy of formation of what, 0. Why? Because naturally occurring. Only there will be sensible enthalpy to raise the temperature. 031 kilojoule per, so to the standardized enthalpy, okay, of the mixture. Okay, the formula is H bar of mixture is equal to, okay, so note one thing here. Here I am writing 0. Okay, 0 means what, 298 Kelvin and 1 atmospheric pressure. This is what the standard condition. Okay, also write down that state. Standard state can be changed. For example, in your question 300 Kelvin and 1 bar mentioned, then you have to take as 1 bar, because 1 bar 1 atm is not same. Okay, 1 bar 1 atm is equal to 1.01325 bar. Okay, so this is not same. 1 bar 1 atm different, so slight change in the value leads to bigger error in your final answer. Okay, don't do that. Whatever the standard state given in your question, just calculate bar of mixture, standardized enthalpy of the mixture. Okay, what is the formula? Summation of xi hi. Okay, I am not stopping for you to give the answer, what is the calculation result. Okay, if I do like this now, we cannot cover too much question. How much problems I will go through, that much help in your. Okay, I wait for you to solve it in calculate and then and the process very slow, not going to learn much of the information. I'm not stopping, but if you have any doubts, you feel free to ask. Okay, at any point you are not understanding, just ask. Okay, I think I'm going in a very slow pace. How much we can go, but these are, I think, basic. Okay, I'm not actually solving very difficult question, and I don't think so this much more than that the difficult question not going to come, I think. Okay, what basically I done, x of CO2 already found out 0.1. Okay, and x of O2 already given 0.9. Okay, these are whatever values I am putting na, just don't confuse, these values I taken from the book. Okay, what is okay, actually not from book, actually this is, I think already I calculated all these things. Bar of CO2 already calculated, and h bar of O2 I already calculated. 3031 and minus 389.45. These values are whatever values you will take from enthalpy of formation and sensible enthalpy. All these things are available in your appendix A. Okay, all the lots of appendix are there. You just go through all these appendix once. Okay, today maybe you can go through whatever the appendix, all these things. Okay, Saturn book 3rd edition. I think this book, all the details also available in your lecture 1. If you see initial some minutes, it will available. Okay. Calculate all these things, then 36226 of your answer. Maybe the last process.
So negative sign means heat is being released.
No. Actually, what the thing is, for example, a mixture means you have to supply some means heat. Okay, negative means always you have to add some heat. You see, you see here for CO2 now. For CO2, for making this CO2 happen, we have to. This is minus 393454546, whatever it's coming. Okay, it means we have to supply this much amount of energy to make our product CO2. Okay, it is required to make the product. Okay, that's the reason negative sign is. And positive sign, that means heat is releasing from that thing. That's what the idea. Okay, so here negative sign means that means for making this whole product, whatever mixture of this O2 and CO2 and O2, you have to supply this much amount of heat. That's the reason. It's also called standardized enthalpy, okay, of the mixture. Not also standardized enthalpy. Negative sign means we have to give that. That is supply. You get it, na? Okay, go to next. Determine the molecular weight of a stoichiometric. What is stoichiometric means? Equivalence ratio equal to what? 1. By your equivalence ratio, which is equal to 1 for a methane air mixture. Okay, so these are very tricky questions. Okay, maybe this kind of question you can expect in your IES, your EPSC IES prelims, or in maybe in your mains. This kind of question you will expect. The question will be only one line. Explanation is not one line. It's very difficult. Okay, this kind of tricky. Okay, in the question nothing is okay. How to approach this question? Whatever we learn, just to apply in one idea. What are the things given? Geometry mixture of geometric of what? Need to find the molecular weight of the assumptions we have to make. Air only contains 21% of oxygen and of oxygen. Because there will be in area in air, there won't be only oxygen, nitrogen, some other gases will be gases here. So carried assumption, nobody questions about. To write down any hydrocarbon based reaction, write down like this: XHY O2 6 8 times O2 plus air. Any kind of species, any write down the, you have to find constant by balancing the reaction. What is the number of carbon? What is the number of hydrogen? What is the number of balance left hand side and right hand side? Okay, product and reactants will get your okay. Question at least if the fuel is given as methane, so we can H4 what will be the case? H4 means what is X here 1, what is Y? Okay, what is A? X plus Y by 4. This is the formula you should remember. Okay, A equal to 1 plus 4 by 4 is. Now if you write down the again the reaction H4, because in the previous reaction very carefully, the reaction having only two unknowns, one is X and the whole reaction reactant side and product side, if you see only X and Y are there, X, Y and A, basically three unknowns are there. Okay, so it's very easy to calculate these three and then directly substitute your reaction. Okay, H4 plus 2O2 plus 10.52 2 into 3.76 2 gives rise to go to 7.5 of moles of N2 of O2 NO4 CH4 by L divided by 10.0.09 2 by 0.19 7.2. Remember this rate of the mixture formula, then we obviously till now I think you get it why I am doing in this direction. Okay, because whatever things we need for the molecular mixture, so that easy. So you have to think like that. How to calculate the molecular rate equal to what? Summation of xi of I. Okay, is your any species. Okay, what you need? You need the x of all the species. Molecular obviously you have the x, you can find out species. I check. I'm telling you. Have all the things. Just the rate of the mixture. You don't solve all the previous question. Obviously, you don't understand how to find out all the previous. Very one more problem. We metric airfoil ratio for the propane. Okay. Liner, we have to find out the airfoil ratio. for air fuel ratio, what we need? Okay, air fuel ratio, molecular weight. Molecular weight we need, and we need the what? A plus y by 4 by equivalence ratio. If nothing given, air fuel is equal to what? Fuel ratio by molar basis into molecular weight divided by molecular weight of the fuel. Okay, air fuel ratio mass basis. Air fuel ratio is equal to what? Well, what is the air? A plus 3.7, A times O2 plus 3.7, amount of fuel basis in A plus 3.7 is 4.7 A divided by 1. Fuel is 1. For fuel, basically you take 4.7 for air fuel ratio. Will come this writing. Rate of air. Fine. Procurement. Mass basis. Air contains 21% oxygen and 79% nitrogen. Okay. Propane plus 3.76 to uh, 8 by 2 equal to reactions, and 2 will come in also in the what product. Nitrogen obviously mostly now nobody will mention, but yeah, for making it a balanced reaction, we will write down only CO2, nitrogen no cut. Correct way. X equal to y is equal to 8. Y is equal to 1 we assume. A is equal to the actual formula of A is this is the actual formula. X plus y by 4 divided by 5. Y is here what? 1. I nothing given means 1. Okay. X3 y8 if you solve 8 or your A as 5. Okay. A plus 0.76 divided by here this is your what? 12. Okay. 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 Also one very good formula. air fuel ratio in divided by okay. So 4.75 for the air, 20.85, 44.296. Okay. In 0.6. If question, for example, equivalence ratio they will okay. Briefing. If you want to, what is equivalence ratio? Air fuel ratio, geometric, divided by air fuel ratio. Okay, got the note. And for this 15 you will get, okay, this is your what stoichiometric. Then don't need to get, for example, in your question they want to find out phi value. Okay, want to find out the phi value, that initially you have to take obviously phi 1 and solve up. Here you assume phi as 1. Okay, solve up to this because they are asking for phi value. We cannot assume any, just assume. Okay, if you have this and they have to give the what actual air fuel ratio. Ask what is equivalence ratio, then obviously you can. Also one type of question can be phi equal to, get the phi equivalent. Thank you very much for record this section. Have the recording. I will put in Sagar Hota. That's okay. Get my name type down, and if you obviously you should meet Saturday. Wait. Okay.
Right. Thanks. Sir.